Good afternoon. It's Chemistry B, Unit 7, Acids, Bases, and Salts. Oh my. This is day 5. Let's get started. We're going to talk about acid and base reactions and how they will relate with neutralization reactions. And that, remember, if you mix a solution of a strong acid containing hydronium ions, what are hydronium ions? H3O positive. With a solution of strong base that has an equal number of hydroxide ions, a neutral solution will result. Hydroxide is what? OH negative. So here's an example. We have hydrochloric acid and we have sodium hydroxide. When those two combined, they will produce sodium chloride and H2O, water. Okay? The process in which a neutral solution is produced when an acid and base combine to produce a salt and water is called neutralization. In the hydrochloric acid example, the strong acid, HCl, is equal to the number of hydronium ions, H3O positives, are equal to the NaOH. Therefore, we get a neutral solution being produced. Okay? So if I took 1 mole of hydrochloric acid and combined it with 1 mole of sodium hydroxide, then we would get sodium chloride and water, and it would be a neutral solution. All right? But remember, the key here is this has to be in the exact mole ratios of a balanced equation. Okay? So it can't just be, oh, I have a strong acid and I have a strong base. Put those basages together and what do we get? No, they're not going to be balanced. They're not going to be a neutral solution unless they are the exact mole ratios of a balanced equation. Okay? When acids and bases react, they will generally form a salt and water. Yes, table salt, but that's not all. Of course, we have potassium chloride, calcium chloride. All right? Those are examples of a salt. The sodium bicarbonate, NaHCO3, should not be listed in there, so just ignore that. All right? Salts are compounds consisting of an anion from the acid and a cation from the base. Okay, now let's switch gears a little bit. Remember, a salt consists of an anion from an acid and a cation from the base. Well, that's just what I said. All right, it forms as a result of the neutralization reaction. Okay. Oh, I see I got my order screwed up here. All right, so that's H3O positive plus OH negative produces H2O and H2O. All right. Sometimes salts can be acidic. Sometimes they can be basic. Not just a neutral substance. Okay. Now what is going to be, see now look, that's hydronium ion, hydroxide ion, water and water. This thing's all screwed up. Well, you'll figure it out. All right. Determining if a salt solution is acidic or basic. If it's a strong acid plus a strong base, and they're of course of equal moles in a balanced reaction, balanced equation, then we know they're going to be a neutral solution. If it's a strong acid plus a weak base, then it's going to be an acidic solution, acidic salt. If it's a weak acid and a strong base, then it's going to be a basic solution. Okay, let's switch gears to buffers. What is a buffer? All right. A solution in which the pH remains relatively constant when small amounts of acid or base are added. Buffers are solutions of a weak acid and one of its salts, or a solution of a weak base and one of its salts. Okay? Think of the idea of a buffer as something that is going to protect you from something else. So let's take a look at sometimes what people will do is if they know they're going to be eating some acidic food, they will take a base prior to them eating, and that will make the food less detrimental to their stomach, especially if they don't do well with acidic foods. So that taking that base acts like a buffer, okay? But buffers in turn are a solution in which the pH will remain relatively constant when small amounts of acids or bases are added, okay? So a buffer will resist change in the pH. That's why we use them. We use buffers to resist the change in the pH. Now, it will only resist a small amount. If you put too much of an acid or a base in there, then that buffer will not be able to protect because you've given it just too much. So it'll only do a small amount, all right? The amount of acid or base that can be added to a buffer solution before a significant change in pH occurs is the buffer capacity. Example, we need buffers to maintain our human blood pH within a very narrow range. So our normal blood pH, like I said earlier in the lectures, blood pH switches here and there. Right now we're going to use 7.35 to 7.45. All right. Our body has natural buffers in it that will allow for our human blood to stay in that very narrow range. If our buffers aren't working properly, then our pH gets out of whack, and that can have some serious effects.